Hello, Algebra 2 students. Okay, this video is definitely math related. We're going to go through each of the examples on here. Again, stop, pause, rewind, mute, fast forward. Here we go. When I look at example 1, I have to say to myself, step 1, is the radical isolated? And it's not. When I say the radical is isolated, that means this needs to be by itself. So in order to get it by itself, I'm going to subtract 1 from both sides, which gives me the cube root of x minus 5 is equal to negative 2. Okay, friends, remind yourselves, powers and roots, they undo each other. So step 2 is to raise both sides to the power that undoes the root. Because this is a cube root, I'm not going to square both sides. I'm going to take both sides to the power of 3 so that this 3 and this cube root undo each other to yield an x minus 5. Now, if you don't know what negative 2 to the third power is, let's use our calculator. I'm going to have negative 2, and I'm going to raise that to the third power. And notice you're looking in the top left of the screen. I get negative 8. What do we have left, friends? Well, this is an x to the first, so this is a linear equation. So step 3 is to solve it. I'm going to solve it by adding 5 to both sides, so x is equal to negative 3. But we're going to get into a good habit of checking our answer. Pardon me. So if I look at the original problem, I have the cube root of x minus 5 plus 1 equals negative 1, but I'm going to change out that x, and instead of the x, I'm going to write negative 3. Friends, you should be able to use your calculators and type that in exactly as you see it. All right, so let's see if I can get this to work. And let's see if I can get a cube root on here. Here we go. Oops, I didn't clear that. All right, let's get the cube root. So I want the cube root, and I have negative 3 minus 5. All right, then I'm going to go on the outside of it, and I'm going to add 1. So do you see how I can just type in that whole left side on my calculator? And this is negative 1, and negative 1 equals negative 1, and that checks. Example 2, we're going to start to get more rigorous. This is going to be a problem that is going to take a little bit more thought. Ready? I have 3x plus 4 to the 2/3 equals 16. First thing, is the radical isolated? And you're like, what radical? All right, didn't we learn before spring break that I can rewrite this as a radical? That's why we spent time doing that. Remember, I have 3x plus 4 to the second power because it's power over root. And then the root is the cube root. So there's my radical, friends. And it is isolated. I'm not adding or subtracting anything to it. All right, the next thing we have to do is we have to power it up. This is a cube root. So I am going to choose to power it up by taking each side to the power of 3. That means this 3 and the cube root undo each other, but this is what's different. I'm left with 3x plus 4 to the second power. And if you don't know what 16 to the third power is, okay, we're going to take 16. We're going to raise it to the third power, and that gives me 4096. We're going to get some big numbers, friends, like really big numbers. Okay, so we have 4096. Okay, this is what's different. It's in the solve piece. This is what is different. In the previous problems that I did, all right, we ended up with something that was linear. We ended up with something that was linear. This is not linear anymore. In this problem, this is now a quadratic because you have the power of 2. So in order to solve it, remember powers undo roots. So now what I have to do is to undo the power of 2, I have to square root both sides. The power of 2 and the square root undo each other, leaving me with 3x plus 4. And then the square root of 4096 is equal to 64. But friends, this is what you have to remember. Whenever you take an even root, so whenever you take an even root on both sides, I believe there's like a fourth root problem in your homework. You guys, you get a plus or minus. So again, whenever you are taking an even root, you have to get the plus or minus. So this breaks this down into 3x plus 4 equals a positive 64, and 3x plus 4 equals a negative 64. Now I can solve. I'm going to subtract 4 from both sides. 3x is equal to 60. Divide both sides by 3. So one solution possibly is x equals 20. I'm going to subtract 4 over here. So I get 3x is equal to negative 68. And we're going to get an unsavory fraction. Let's check our answers. Okay. Reminder that the original problem was 3x plus 4 to the 2/3. So I have 3 times 20 plus 4 to the 2/3, and we need to see if that is 16. So right now you're only checking 20. You can only check one solution at a time. All right, you should be able to put this left part into any calculator. So let's check it out. Come on. Oops, what happened here? There we go. Come on. So I've got parentheses 3 times 20 plus 4, close parentheses, and I'm going to raise that to the 2 divided by 3 power, and it does indeed give me 16. So 16 is equaling to 16. This is a solution. Now I have to check negative 68/3. So let's change color here. I need to see if 3 times negative 68 over 3 plus 4 to the 2/3 equals 16. All right, let's use our calculator. So I'm going to do 3 times negative 68 divided by 3, arrow out, plus 4, and I am going to raise that to the 2 divided by 3, and friends, that is indeed 16. So this question, or this problem, had two answers. X is equal to 20, and x is equal to negative 68/3. All right, let's do example 3. On example 3, step 1, isolate the radical. The radical is isolated. If I look at this radical, it is all by itself. Step 2, we need to power it up. Since I'm in the square root business, I'm going to power it up by taking both sides squared. This is what makes this problem irritating. The right side is easy. The square and the square root cancel, leaving me an x plus 10. But on the left, friends, hello, you can't just square the x and the 2. This means x minus 2 times x minus 2, and this is what makes the problem a little bit more complicated. All right, step 3 is to solve, and this is where kids get frustrated. Are you ready? On the left, I have to FOIL. First, outer, inner, last. Friends, this made this a quadratic. In order to solve a quadratic, it has to equal 0. So I'm going to subtract x from both sides and subtract 10 from both sides. This gives me x squared. When I combine those, I get a negative 5x. And when I combine the 4 and the negative 10, I get a negative 6. You can use quadratic formula, but I'm going to choose to factor. I need to think of two numbers that multiply to -6, but at the same time add to -5. Those two numbers are going to be a -6 and a +1. -6 plus 1 gives me -6, and -6 plus 1 is -5. So if you need to do the AC method, do the AC method, but we get x minus 6, x plus 1. Next, I'm going to use the zero product property. So x minus 6 is equal to 0, and x plus 1 is equal to 0. So x is equal to 6 is one possible answer, and x is equal to -1 is a second possible answer. But again, what do we have to do? We've got to check our answer. So let's go back to the original. I'm going to get rid of all of that so you can see what it looked like. Our original problem was x minus 2 equals the square root of x plus 10. Okay, instead of the x's, I instead am going to fill it in with 6. Okay, remember, I can only do one at a time. I can't fill it in with the 6 and the -1, just the 6. Well, 6 minus 2 is 4. I don't need a calculator for this, but feel free to use one. And the square root of 16 is 4. That checks, so that means x equals 6 is a solution. Now let's check -1. When I check -1, I get -1 minus 2 is equal to the square root of -1 plus 10. Well, this gives me -3. This gives me the square root of 9. Friends, the square root of 9 is 3. What happened? You guys, you didn't do anything wrong. You have to check your answers. In this case, let me rewrite. That was kind of sloppy. -3, you guys, that does not equal 3. That means x equals -1 is not a solution. How can you let me know? Just like I just did. Cross it out or just highlight the correct answer. So friends, this problem only had one answer. And when kids ask me how I'm going to know, you don't. I don't care if you're an Algebra 2 kid. I don't care if you're an honors kid. You have to check your answer. If there was a shorter way to do it, I promise I would teach it. So final answer to this problem is just x equals 6. We call x equals -1 an extraneous solution. Extraneous. You don't have to write that. You don't have to spell it. Just cross it out in your work and highlight or circle the one correct answer. Some kids will ask, is it possible that both don't work? Correct. It's possible to have no solution. I didn't give you any in the homework, but that is a possibility. Okay, 2 more examples. Okay, step 1, are we isolated? And you're like, everyone pay attention. This is an intentional problem. Remember how I don't give you 47 examples. When we rewrite this, the 4/3 is only on the x, not the 2. The -2 stays on the outside. Only the x is being raised to the 4th power cube root. Is the radical isolated? Heck no. When I say that radical is isolated, I'm only looking at what I have highlighted in green. So how do we get rid of it? Well, first I'm going to add 21 to both sides. And 53 minus 21 gives me 32. That'd be a -32. I had my signs wrong in the calculator. All right, next we're going to divide both sides by -2. And now the cube root of x to the 4th equals 16. Now I have the radical isolated. So that was step 1. Step 1 was isolating the radical. Step 2, we power it up. Well, this is a cube root. So we're going to choose to power it up by using power of 3. So the power of 3 and the cube root undo each other, yielding an x to the fourth. And if we don't know what 16 to the third is, I think we've done it earlier, but let's do it again. All right, 16 to the third power is 4096. Again, you are going to be getting some big numbers in this process. All right, now we have to solve. Okay, and you're like, nah, we haven't done this before. Okay, let's use our brain. We've talked about how powers and roots undo each other. Well, this is an x to the fourth power. So that means to undo it, I have to undo it with a fourth root. The 4's cancel. But remember how we talked about earlier, this is an even root. That causes a plus or minus. And when I go to my calculator, all right, I need to do a fourth root of 4096. You can also use the powers that help me, and we get 8. All right, but what do I have to do? We have to check our answer. So when I check my solutions, I get -2. I'm going to use positive 8 first to the 4/3 minus 21, and we have to see if that equals a -53. So let's type it in and see if that works. All right, so we have -2 times 8 being raised, and I already forgot, let's double check what that was. It was to the 4/3 power. And then we had to subtract 21. And that indeed equals -53. So 8 works. Now I need to check -8. So this is -2, -8 to the 4/3 minus 21. Let's see if that is equal to -53. And that's not what I want to do. I want to go to this one. All right, I'm just going to go, hopefully, there we go. I can just add the negative. And it's still -53. So both of them work. Uh-oh, here we go. All right. Both of them work. So that means x equals plus or minus -8 is my final answer. All right. And here is our last problem, if I can scroll over there to get it. Okay. X plus 2 equals root 2x plus 7. Step 1, we need to see if the radical is isolated. It is. Step 2, power it up. I'm in the square roots, so I'm going to power each side to the power of 2. The right side is easy. The power of 2 and the square root undo each other, but be careful. That left side is x plus 2 times x plus 2. So we've got some algebra on our hands. Here we go. For step 3, to solve, x times x is x squared plus 2x plus 2x plus 4 equals 2x plus 7. Friends, this is a quadratic. It's quadratic because of that power of 2. So this has to be set equal to 0. So how are we going to do that? We're going to subtract 7 from both sides and 2x from both sides. 2 plus 2 minus 2 gives me 2, and 4 minus 7 gives me a -3. Again, you can use quadratic formula if you would like, but I'm going to factor. I'm going to ask myself, what two numbers multiply to give me a -3, but add to give me a 2? And those two numbers are going to be 3 and -1. 3 times a -1 is -3. 3 plus a -1 is 2. If you need to AC it, please do so. Next, I'm going to use the zero product property. And I'm going to solve. And so I get possible answers of -3 and 1. All right, this is it. This is our last check. Are you ready? We have to check our answers because sometimes we've had them where they have worked or one worked. So let's do our check. Again, you must go back to the original. All right, so when I look, I'm going to check -3 first. So that would be -3 plus 2 is equal to the square root of 2 times -3 plus 7. All right, -3 plus 2 is -1, and let's check the other side. 2 times -3 plus 7. All right, so let's check it. All right, so I'm going to hit the square root of 2 times -3 plus 7. Uh-oh, we get a positive 1. You guys, those don't equal. So that means x equals -3 is an extraneous solution and doesn't work. Now let's check our answers for problem 1. For problem 1, or excuse me, for our solution of x equals 1. So here's our check. We're going to have 1 plus 2 equals the square root of 2 times 1 plus 7. 1 plus 2 is 3. Let's check 2 times 1 plus 7 underneath the square root. And we get 3. So that works. So that means x equals 1 would be my final solution. Friends, you did it. You made it through. So your learning opportunity, I have a missed number in there. It's going to say Unit 6. My apologies. And that should be in an assignment post on Google Classroom. And this is your work for Wednesday through Friday of this week. Reminder, 10:30 is when I am available on Google Meet. And I also wanted to let you know there is a post on Google Classroom that Mrs. Elias in ASC is available. Look for that post. I believe she has office hours from 9 to 11 a.m. and I believe from 1, a.m. and 1 to 2 p.m. I hope you enjoyed. Talk to you soon.